Hey guys, welcome back to our short video series in which we're creating a number recognizer in SwiftUI. In the first part of this series, we created the machine learning model using TensorFlow and then ported that model over to CoreML. In this, we're going to be using that model and implementing it into our SwiftUI application so that we can create the actual app. So we're going to be going over the SwiftUI code, how we interface with our model, all that fun stuff. So let's just jump right into it. Okay, so over here I have Xcode pulled up. I'm just going to hit create a new Xcode project. Next. And we can just name this number recognizer 3 or whatever number. This is my third iteration of it, so I'll just name it 3. Team we don't need. Interface SwiftUI and language is Swift. Okay, so inside of SwiftUI, we're just going to be building our project, so we don't really need these previews. I'm just going to go ahead and delete them. And then we're good here. And we're going to be using the content view file, and then we're going to add one more file, so we can do Command N. And this file will be a SwiftUI view. And I'm just going to name this file drawing area. And likewise, we can also delete this preview. So starting off inside of our content view, the first thing we're going to want to do is take out this text from our body and then add 3 state variables. So we'll do state var showing alert equals false. State var eraser, this will tell us if our eraser is on, equals false initially. And then one more, state var pixels, it's going to be an array of double equals array repeating 1. Count is 28 times 28 because there are 28 pixels in our image. Okay, inside of our view, we're going to add a VStack, and we're going to have our drawing area, and then we're going to add an HStack. And then inside this HStack, we're going to define a few buttons. But before we do that, let's first go into our drawing area and add our variables. So we're going to have binding var showing alert, Boolean, one more for eraser on, and then we're going to add one for our pixels, and then we have one more. Change this to binding, and then we have one more. This time it'll be state, and this is frames, and this will be an array of CG rect, core graphics rect. So we need to make sure we have import. Actually, I guess we don't really need that. Okay, and then we can just say array of repeating, just basic CG rect initializer, default initializer, and then the count is also 28 times 28. And these are bools, not Boolean. I'm switching between Java and SwiftUI, you get confused between the two. Okay, yeah, we don't need this initializers with pixels. We can just have it like give it the type. So inside our body, we're going to first add, we're going to first focus on our drawing area, and then we'll come back to the content view. So the first thing we want to do is we're going to be using a lazy vgrid to make our tiles or our board almost show up as pixels. So to do this, we can do lazy vgrid columns, set this to columns, and then we have to define columns up here. We can say let columns equals array of repeating grid item. The spacing we'll set to 0, and then the count is 28. So each of these represents one column. Each grid item with a spacing of 0, there's 28 of them, so there's 28 columns. Okay, and then we can also add the spacing here to 0. Okay, and now inside of here, we're going to want to add a for each. 0 to the number of pixels, actually one less than the number of pixels, and then we'll just do self. And then we add a closure, index in. And for each index, we're going to add a rectangle. Set the foreground color to color of white of pixels index. So whichever, as you can see, we define pixels in here. So each of these has a value of 1. So when our drawing is first drawn, each of these pixels of index will be set to 1, and each rectangle will have a color of white. And then we're going to want to add an overlay. And inside of this, we have a geometry reader. And we add another closure, geometry in. And we can add a color, so we'll just say color.clear. And then on up here, we want to add a closure and just say frames of index equals geometry.frame in the global coordinate space. Okay, let's fix that to pixels, and we should be good. So as you can see, for each pixel in our pixels, which we defined out here, we are basically turning it into a rectangle, setting the color to the pixel value, and then on top of this, we're overlaying a geometry reader. And the point of the geometry reader is it so we can kind of get a bounding rectangle for the pixel we're creating. And then when we have a drag gesture or a tap gesture, we basically check if that gesture is inside of the CG rectangle, this array of CG rectangles, which is set right here. And if it's inside of that, then we subtract a little bit from its pixel value. So you'll be able to see that in a second once we define our gesture. But for now, we're just going to add a few things. We're going to add an aspect ratio just so this looks nice. 1, and then the content mode is .fit. We add the frame. Set the max width to infinity. And the alignment to center. And then we set the gesture to swipe gesture, which now would be a good time to define. So we'll go up here and we'll say var swipe gesture of type some gesture. And then we can create our drag gesture right here. We'll say the minimum distance is 0 and the coordinate space is global. Oops, didn't mean to put a closure there. And then we can say on changed, value in. And then what we're going to do here is we're going to see if we can obtain a match for our coordinates. So if let match equals self.frames first index. So the first index where we pass a closure, where the so we're iterating through frames. So each CG rect, if our CG rect contains the value.location, then we can say if the eraser is on, pixels of match equals 1. So when we start off with all our values set to 1. So if we have our eraser on, we basically want to reset that value. So we'll set it to 1. Otherwise, we want to subtract, or actually, we don't want the pixel value to be less than 0. So we'll just say max of pixels match minus 0.25 and 0. So if it ever gets less than 0, then it'll just automatically be set to 0. Looks good. This should be set to count also. Another little typo there. And then we can add a few more things just so that this looks a little bit more pretty. We can set the background to a rounded rectangle with the corner radius set to 25, and we can set its foreground color to white, and its padding, we can add some horizontal padding, and then we want to add to the bottom of our drawing area some padding as well. Okay, so with all that being done, our drawing area is pretty much complete. And now we can get started on the actual implementation of our machine learning model into our application. Okay, so now that we're done with the drawing area, we're going to head back over into our content view and finish up our application. So the first thing we want to do is we want to actually pass our state variables into our drawing area. So we can do pixels, and we can do a binding to pixels, showing alert, and we can do a binding to our showing alert. And also eraser on, and just pass a binding to that. Okay, cool. And then inside of our H stack, we're going to define a few buttons, the first of which, 3 buttons in particular. One's going to be to give us our prediction, the other one is going to be to toggle our eraser, and then the third is going to be to kind of clear the canvas. So the first one we'll do is the prediction button. So we can do button action and showing alert equals true. And then we want to pass in our what the button is going to be displayed as. So it's going to be an image and system name. So it's going to be one of the system images. And we can just do question mark dot diamond. So you'll see what this image looks like in just a second. And then we want to add a few attributes. We can say resizable, and then the frame is going to have a width of 35 and a height of 35. Now I want to add a few more things onto this. We want to say button style is at button, and the color we'll pass in is button color. So this is something that we're going to define in a minute. So actually I'll just blank this out. And then we can add an alert to this button, and we'll just say is presented. So depending on showing alert, this alert will be presented or not. And we toggle showing alert right here. And then we're going to have an alert of title set to text, prediction from image. The message is going to be text of predict number from pixels. So this is a function that we'll define in a second. Yeah, here we go. And then dismiss button is just going to be a default text. All right, so the next button we're going to add is of action, and this one will toggle our eraser. This one we'll just do eraser on dot toggle, and then same kind of setup as this one. We're going to do, so we're just going to copy this, paste it in here. But the image is going to be a little different. For this one, we're going to do pencil dot slash. Okay, beautiful. And then we want to add button style one more time, but we will gray that out and come back to it. The final button, this button is to clear the screen. So the action is going to be for index in 0 through pixels dot count. We want to just set pixels of index equal to 1. So resetting each pixel to its original value of 1. And then we can have the same sort of display. And I'm using Vim key bindings for VS Code. If you guys want to use them, I think it's up here in an editor and Vim mode. Yeah, just select that. Okay, and then we want to change this image to just trash. So it'll show up as a trash can. And then one more time, we will copy this button style line so that we can come back to it in a minute. Okay, cool. And then we want to add a few properties to our VStack. So we'll say frame max width dot infinity The max height we'll set to infinity as well. And the alignment we'll set to center. The background we can do color.blue maybe, that could work. I have a custom image for mine, but we can just go with that for now because we're not really focusing on much of the styling yet. And then we want to do one more, ignores safe area. Okay, so we have this function up here, predict number, but we haven't implemented that yet, so that's going to be the next thing we'll do, and this is the most machine learning part of the this application build. Okay, so we'll do private func predict number, and then we want to do from pixels, and then this is just going to be an array of doubles, and it's going to return an integer. Okay, the first thing we'll do is we will initialize our model, but to do that first, we need to actually drag our model that we created the other day into our application. You can just press finish. And now we should be good. So if we just do eminence image recognizer, that will initialize our machine learning model for us. And we can do guard let tensor input equals try ml multi array. First we need to make sure we import core ml. Okay, so we want ml a multi-array, and the shape we're going to pass in, which is 128 28 1. If we look over here in eminence image recognizer, we can see that our input shape is float, or our type is float32, and our dimensions are 128 28 and 1. So you can see we match that right here. And we'll also match the type, so we'll say data type equals float32. And if this fails, we will just print could not create tensor input and return an integer of -1. So the next thing we want to do is we want to populate our array with our pixel data. So to do this, we can say for I in is 1 to pixels dot count, and we just want to set tensor input of I equal to ns number value is going to be float32 of 1 minus pixels of I, right? The shading, the numbers which are closer to 0 are going to be darker. They're going to be closer to black. So we want to kind of, let's say the pixel value is 25. We'd want that to show up as 75 because it's shaded more deeply, if that makes any sense. Okay. And then we want to say do. So we'll do let prediction equals try model.prediction input, and we can just pass here our tensor input. Now if we look over here in its image recognizer, we can see that this is actually named input 1, so we will specify that here. This is input 1, not input. And then we want to do return find max of prediction.identity. And then we will catch this. If this doesn't work, we can just do print error making prediction, and once again return a value of -1. So you might be asking yourself, well, what is this find max and the prediction identity? So we're going to fix that in a second, but first let's observe what our output is. It's an identity and it's a multi-array of float32. So we know that this identity is a multi-array of float32. It's not our integer value, it's an array. So we're calling this find max method that we will define in a second so that we can actually figure out what that value is. So down here we can say private func find max of tensor ml multi-array, and it's going to map to an int. Okay, so we'll say var max, and max index is an int, and we can say for I in 0 to tensor.count. So if this is an ML multi-array, or if this is an ML multi-array, we're iterating through each element in it. And we want to say if tensor of I dot float value is greater than our max. So this max is actually a probability. So if you remember from our previous video, when we're classifying our images, we are left with a probability distribution. So if the probability of that it is this number is greater than our maximum seen probability, then we can update the maximum seen probability and also the index, which the index corresponds to which number we're choosing. So we'll say max equals tensor of I dot float value, and max index equals the index, which is I. And then all from here, we just want to return the max index. So now that we have everything defined, let's go back and make sure that we don't have any bugs. So it seems like there's a problem here. Let's check. So I basically just had to redefine the order of these three elements. Not quite sure why it's finicky about that, but just make sure that the order of these elements is matching the order you define them here. Okay, so I'm going to try to build the application now just to see if it's working, and then we'll go into some more styling afterwards. Okay, so we can see that our drawing area is showing up pretty well. Okay, so let's just try and draw in an image and then see if we can correctly get a prediction. So if I draw in an image, let's see if we get a correct prediction. You can see the drawing process is a little tedious, but yeah, that might be a future improvement. Okay, I think that should be good for an 8. And yeah, prediction from image, 8, perfect. So, our code is working, we know that everything is working, except the styling is pretty bad, let's be honest. So, let's improve that. The first thing I want to do to really improve the styling is make these buttons more visible. So down here I'm going to do struct app button. It's going to be of type button style, or it's going to conform to. And we'll say let color be some color, and then we're going to add func make body configuration of configuration, return some view, and then we can say configuration.label. And so we're going to add padding, we're going to add a background color, and it's just going to be our color. We're going to add a foreground color, which will be color of red is 128. Make sure to divide these by 255, green 0, and blue 0. And then we'll add a clip shape, and we're just going to say rounded rectangle of corner radius of 10, and then we're going to add some padding. And then up at the top we want to add a button color, so this will be a color for all of our buttons. So we can say let button color equals color of red 250 divided by 255, green is 240 divided by 255, and blue is 230 divided by 255. So inside of this button style, we're going to want to say button style is app button of button color. This one's perfect. For this one, we want to say app button, but this color is going to depend on whether the eraser is on or not. So if the eraser is on, we're going to say color of red 209 divided by 255, green 190 divided by 255, and blue 168 divided by 255. So this is more of a darker color. And then otherwise, we want to just say our color is the button color. That one's good. And then down here, we can add one more button style. And for this one, it's just going to be our app button color, button color. Okay, and then also, I want to change this background color. So to do this, let's choose, I had a hardwood background before, so kind of like a nice picture of wood, so it's like almost like you're drawing on a piece of paper. So let's do that. Let's try and find a picture of a wooden background, and we'll use that as our background image. So this image right here looks good for us. So we'll just do save image as. I'll include a link to this image in the description. I'll just say background image and save it to my desktop. Okay, we can replace that. Okay, so basically this process is pretty simple. We just want to drag our, let's actually open our assets first. We want to drag this into here. And we're pretty much good. Now we can just go back to content view and set the background to an image. And we can just say of background image. It is resizable. The edges ignore safe area. And the frame, we'll just set the width equals UI screen.main.bounds.width. The height is UI screen.main.bounds.height. And if we build our application, hopefully this will work and we'll be left with our finished product. Perfect, our app is looking beautiful now. So as you can see, we can draw in our image, we can turn the eraser on and erase some of these pixels, and then if that's not working, we can just clear it. So let's give it one more test. Let's try the number 2. So the process of drawing an image is not the greatest. That could be a future improvement, but let's see if it works. And also, I tried my hardest to get the drawing features so that we could make the images as they're represented in the eminence dataset. So in the eminence dataset, you can see that kind of the middle is more distinct than the outer edges of the image. So I tried to model that, but I don't know if I was successful. Some of the predictions aren't that accurate, but we'll still give it a shot. Sweet, so it predicted 2 correctly from our image. Awesome. So I hope you guys enjoyed this this series. Show this app off to your friends. I hope you enjoyed building it, and I hope you most importantly learned something during the process. All right, have a nice night. See you guys.